Hello and welcome to today's webinar. We are very fortunate that we're able to do this webinar today. I'm currently in Foley, Alabama at our calibration lab here. Last night, we did have Hurricane Zeta roll through the area, and there are many locally here that are without power. So we're very fortunate that we do have power and that we do have internet here at our Foley, Alabama campus, where we have our warehouse and distribution facility, along with our calibration and service labs. So I want to thank you very much for tuning in today for the webinar dealing with calibration and how we can calibrate the torque sensors and analyzers. My name is David Cash. I've been with Mountz now for over 15 years. I first started as a territory sales manager, and I've had several different roles throughout the company here. And currently, I'm a member of the marketing team. So as it is with every webinar that you've probably attended here lately, your microphones will be muted. However, you can ask questions, or you can go ahead and make comments in the chat feature. At the end of the presentation here, we'll have the time for questions and answers. So if you do have anything that you'd like to ask, feel free to do that. We'll do our best to answer that question. If I can't, or the other people that I have here with me, then we'll certainly get back with you an answer as soon as possible. So again, I am with Mountz. We've been in business for over 55 years, since 1965. We were the first company to develop the electric torque analyzer for the military in the mid-70s. Since that, we've had 18 different generations of torque analyzers. So we're very confident in our ability to provide you with the ability to properly, accurately monitor your torque. So when we look at the whole calibration process, what we're going to do today is we'll kind of just take a look at the process itself, the equipment that you're going to need to do it if you wanted to bring that in-house, or we can also actually we're going to do a run-through of a three-point calibration here for you this afternoon as well. So with the torque analyzers and the sensors. Now there is a little distinction between the two. The torque analyzer is the portion of the unit that is handling the display, the calculations from the sensor itself. Often we do have sensors that are built into a torque analyzer. For example, our LTT product has the analyzer, the transducer built into it. We also have a handheld analyzer, our PTT unit, that you add sensors to that. That is very portable type of system. So that's kind of the difference between what the analyzer does and what the sensor does. And in this case, the entire package is a fine-tuned laboratory measuring device. And to maintain that properly and to make sure that it's accurate, we want to make sure that that is calibrated on a periodic, regularly scheduled time for its calibration. And so if we look at what calibration is, it is the method of comparing tools and measuring devices to a higher standard. And so that's what we do when we actually calibrate a torque analyzer. We use a known weight value, and that's a dead weight scale. And again, we'll show you what that looks like as we roll through the process for that. So the typical standards that are associated with the calibration, whether it be the lab itself, or whether it's going to be the tools that are being used, or the actual equipment that's being used, all of those standards are incorporated into a number of these different elements and governing bodies. So there's the ISO 9001, the ISO 17025, or you have the Z540, and then we also have some additional international standards listed as well there. So right now we're going to take a quick poll. We've got 3 different questions that we're going to ask. And the first question on the poll is, Do you currently do in-house calibration? If you, what the actual calibration cycle that you use, and then, or if you use Mountz as the entity for calibrating your torque analyzers and sensors. So we'll go ahead and run that poll now. And we'll give that just a few more moments. Awesome. All right. So that is our poll question. And you will see the results that we have for the different questions there. So thank you very much for participating in that. As we move on with the presentation, again, if this is going to be an internal process that you would like to set up, there are going to be a little bit of an investment that's involved with that in acquiring the correct equipment that's going to be needed for that. In addition to not only the equipment, there'll be an investment in the operators or the team members that you may have doing this calibration. They will need to be trained to the standards. So that would be an additional investment. And then obviously you need a location or a laboratory to be able to conduct the processes in-house for you as well. So the other option to that would be to have an outside service do the calibration for you. And again, that may be more cost effective for you. Here at Mountz, obviously we have 55 years of calibration experience. We have Mountz trained professionals and technicians that work on our tools, and we can calibrate any of our tools or analyzers for you with our calibration service as well. And when you do get the certificates that we have two labs. They're both ISO 17025. The one here that I'm currently in Foley, Alabama. And then we also have one at our corporate office located in San Jose, California. And then so when you do receive the ISO certification from us, it's going to give you all of the information that is related to the service that you requested, whether it be an ISO 17025 cert or a Z540 cert, within the different specifications that you would call for. So that's what you would receive as far as the certification for your particular torque analyzer or sensor. Now, one of the most often asked questions that we get pertain to calibration intervals. So it's kind of a combination of different things that happen. You want to look at the certain amount of equipment that you're using, the application that it's being used on, the amount of usage that it has, and then also the management goals as it relates to managing risk and the ability to tolerate failure. So the standard, well, in this case, we have customers that will ask for their calibration certs every 6 months, and they send their tools in to us every 6 months, or we have other customers that will do it at 12 months. And then again, we have other companies that are on either side of that spectrum. So companies that need a little bit more or have a less tolerance for possible failures will send their equipment in more. And then we also have other companies that may extend out that particular interval. But the calibration interval, again, relies on those factors and is set to us by you. When we look at the particular equipment that is used for the calibration of the analyzers and the sensors, there are, again, the national and international standards that are adhered to. So the different pieces of equipment that are used can be traceable to either ISO or to NIST. the National Institutes of Standards and Technologies. So there is another step within that calibration process that is being used to then be traceable for the tool that you're being used. So for example, if you have a torque screwdriver that you're using out on your line, you have an analyzer that you use to validate or calibrate that particular tool. That tool is then traceable to the cert for that analyzer. If that analyzer was calibrated at our facility, then its cert is traceable to our standards here and our equipment. And then the equipment that we have is then traceable to NIST as well for some of the other equipment that we need to send out to have analyzed and calibrated as well. So there is a long line of traceability that happens from the very beginning all the way to your torque screwdriver. So the different items that we use for the calibration process, for very low torque analyzers and sensors, we use the calibration wheels. So these allow us to be able to give a known weight at a very low weight value. And that would be for the different low-end torque values. For the larger units, larger transducers, we would use segment arms. And these segment arms range from anywhere from 10 inches up to 48 inches in allowing us to be able to test at different known weights. And the other items that would be needed would be the mounting brackets. So either mounting the analyzer or the transducer to a bracket to make sure that it is level. Would also be equipment that would be needed. And you'd also need hangers to be able to hang certain weights to be able to replicate the certain values that you may need at a given known weight value that you may need. And then finally, the different weights. So all of this equipment is sent out to another facility to be verified and or calibrated, everything except for the brackets for this particular calibration process. So in essence, how does this entire thing work? So first we have the analyzer itself. It is married to a sensor that we're using, and it all starts with a strain gauge for our reaction style transducer. So the strain gauge is a very small electrified circuit that is laminated onto either a rod or a bar. And as we apply torque to that particular rod or bar, we do see torsional forces that happen. And then any flex or any movement in that strain gauge is going to allow us to measure any type of resistance that happens during that particular torsion. So we can make a correlation between what happens at one value or one torsional event of resistance versus it at its resting state. And we can then take that analog input of turning, whether it is a screwdriver or a wrench. We then can manage what that resistance is as it's being done, and that electrical resistance is then correlated to the torque value. So that's kind of how it happens, and we have an animation here that's going to kind of demonstrate that. It is a bit exaggerated in the amount of movement that you would see in the strain gauge, but it's just to prove the point as at what happens to the strain gauge as there is torsional forces that happen on the sensor. So that's how we're able to take the analog signal and convert it into digital. And so what does that look like when we do the setup on the actual models that we're testing? So first we have our transducer, which is mounted into the bracket. And then we add a segment arm to that. And then from that segment arm, we add our different hangers and weights at the known values, or excuse me, the known weights that are needed to calibrate the particular sensor that's being used. So in most cases, we have either a call out for a 3-point calibration, or it's going to be a 5-point calibration. So in the example that we are showing today in this process, we're going to be calibrating a 500 inch-pound sensor on a 10-inch wheel. So if you know the standard formula for your torque, it's distance times force, is going to give us the value of torque that will allow us to have our known weight value. So when we're looking at this, we're going to be measuring or adding 100% to that. We'll then start the check at 10%, then we'll move to 50%, and then finally again at 100%. So the 10-inch arm allows us to be able to stack the certain weights that we would need. Obviously at 100%, we're going to be using 50 pounds of our weights to give us our known weight value. At that particular point, when the strain gauge is giving us its resistance value, that will be its 100% point, and so on as we move through the particular process of the calibration. So we'll go ahead and bring in our technician now. Landon will go ahead and perform the calibration for us. So now we're just exercising the sensor itself. So we're adding 100% of the value needed onto the sensor. And then we let that marinate for just a minute. All right, and then we can go ahead and make sure that there's no weight onto the sensor, and then we'll go ahead and begin adding our first point at 10% of the value needed. And again, at this point, we're letting the system, the software that's working in conjunction with the analyzer and the sensor to determine at which point the weight is going to be accepted as the value. And now at this point, we just did the measurements the clockwise direction, and then we will do the same measurement in the counterclockwise direction. And then we move on to the next point. And then the final point. All right. And then now, at this point, we'll go ahead and we verify to make sure that the sensor is producing the accurate torque values that we just modified. And we are good. And so in a typical process, the weights that are measured in the counterclockwise and clockwise are done a total of 3 times. There is the first value that is done as taken as accepted, or excuse me, as first presented. Then if there are any modifications that need to be made, we do one more check in those directions as well. And then after that, a final check to make sure that all of that calibration data was done correctly. And that's the process that happens for the calibration of the analyzer and the sensor. So that is it. It's a pretty simple process. There's not a lot of items that, or a lot of complexity to it. There are just the standards that need to be followed. And as it relates to the amount of service that needs to be done for each particular call out. So at this point, we can go ahead and address any questions that we have from any of you. So I'm not sure who's handling the questions today, Chris or Casey.
All right, it looks like Chris may be having difficulty getting his sound to working, so I will start with the questions for you. Sorry about the delay there. So I have a question from James. It says, does the PTT display have any effect on the calibration process? And would we still get the same results regardless of which PTT was used?
Yes, so the typical PTT and analyzer, they can be married as one particular unit. However, the calibration data for the sensor is stored on the automatic recognition chip that we have within the transducer. So let me confer to our top crack team of calibration technicians, and they did say yes, it is possible to be able to use a different PTT with a different sensor.
All right. The next question is, how do you calibrate a dynamic transducer?
So the process is very similar. You just use a different style of bracket that is going to allow us to put the rotary sensor, if that's what I think they're asking, the rotary sensor into a fixture, and then the process is the same. You would hang weights on that dynamic sensor, and it's going to be the exact same process as it would be with the BMX style of transducer or reaction style transducer. The other way, if it's not using that, if you wanted to perhaps calibrate a torque a torque multiplier, then you would use a rotary dynamic transducer, and we do have those as well. And we can measure up to, I believe it's 10,000 foot-pounds or so for any type of multiplier that would need that type of verification.
Okay. I have a question from Luis here. I'm not sure if we'll be able to answer it based on the standards here. It says, according to DIN 5309 standards, you must calibrate the equipment depending on the class of transducer. Why would you only calibrate 3 points, and what classes are the transducers?
So there are different calibration processes that would require you to use more than 3 points. So you could And I believe on the ISO 17025 cert, that's a 5-point calibration. So the Z540 is a 3-point calibration. So it's just going to be dependent on what standard you would need it tested to as to how many points you would be using.
Okay. And then it says, what is your calculation of torque? Do you account for local gravity and air buoyancy?
Yes, that is possible. That is part of the formula to factor in the specific gravity of the location where you are.
So I have a question from Ben. What was the software used to calibrate the sensor in the demonstration?
So this is the, what is it? The interface program, or yeah. So yeah, it's the software that we use for our integration with our products. So either the LTT or the PTT and so on.
Okay. Can the Mountz transducer calibration due date be updated in the field? If so, how?
If you have the software, you can go in and you can change the calibration date on there. That is part of the software, but it is password protected, so it's not something that can be done by accident. You'd have to have the intention of actually changing the date to do that, but it is possible to go in and change that date. But again, it's password protected.
Okay. And then Tom, if you shoot me an email, I can get you connected with the Mountz representative in your area so that they can help you with your specific equipment. And then I have one more question. Oh, more questions coming in. I have one from Tim here. It says, do you ever see results being skewed by excessive downforce on the transducer spindle when using the larger arms?
I would say, yeah, we did. I mean, it's not, we don't see it very often.
Okay. They are saying that it does happen on occasion, but not very often. And when it does happen, it's a minute type of value and may not affect the overall accuracy within the specification.
So Tim, if you want to shoot me an email there, I can get you forwarded to one of our technical support experts if you have any further questions about that specific question. I have a question from Alan here. Does the update firmware in the LTT require recalibration?
I don't believe it does. No, it does not.
All right. So those are all of the questions. Oh, I have more. I have one from Mark that says, how is the calibration software acquired by a lab?
Simply, you can request it from our technical application support team, and they can provide that for you.
Okay. And then I have a question from Paul. What standards would you recommend to run an in-house calibration program?
Again, it's going to be dependent on, again, how much usage is being used, the management goals. So if you wanted to do a 3-point every 6 months or a 5-point every 12 months, it obviously is something that you can track. And if you do see any type of out of tolerance issues over an extended calibration cycle, you could certainly go ahead and half that as far as the time is concerned, and see how that is affected by the overall pattern within that particular sensor. So
all right. And then Paul, if you guys need a consultation, I can get you guys connected with one of our technical support reps as well. I have a question from Dustin here. What major environmental conditions can affect the results of a torque calibration?
So in the lab here, they control for temperature, for humidity, a specific gravity. I don't know if there's anything else that, no, those are as far as the environmental impact to the calibration, but the lab is controlled via temperature and humidity.
All right. And then I have a question from Styles. I don't know if you'll be able to answer this whole question on the webinar, but we may be able to get him started. It says, our company uses your services to calibrate our equipment. How do we go about being able to calibrate the equipment ourselves? Do we need a certification? Where do we start?
So certainly the best place to start would be to reach out either to the Mountz territory sales manager that is assigned in your area. They can certainly look at your application, look at your process, look at the kind of equipment that you may need to have for the type of analyzers and sensors that you are using. They can then go ahead and make the recommendation on the specific equipment. That would probably be the best place to start for that.
Okay, and Styles, I can get you connected with the territory sales manager in your area. I will shoot you an email after this webinar. And then I have Mark. Do you have a webinar to discuss what an uncertainty analysis would look like? I know that we don't have that currently, but Dave, is that something maybe in the future?
It's possible. That may be a discussion that would be certainly a very narrow focus, but we could certainly have that conversation as well.
Okay. Then I have Pedro. What is the minimum class of weight that I can use to calibrate?
The minimum class of weight? I'm not sure I know what that is. As far as the certification for the weights themselves, but we can measure into the low inch ounces for our sensors that we're using. I believe our lowest sensor is around 2-inch ounces, in that ballpark, somewhere around there. So just dependent again on the size of the wheel and then the weight that's being used.
All right. And then I hope that answers your question there, Pedro. If not, I'd be happy to get you connected with somebody to get that a further answer for you. So it looks like I have 3 more questions. I'm going to have to stop with the last question. It looks like from Patek. And then everybody else will have to answer via email. I have one here that says, how would you suggest we perform a gauge R&R for our rotary transducer? Our quality analyst is asking that we perform this task to make sure the transducer is providing accurate data and repeatable range over 10 to 50 inch-pounds. Do it using a 100-inch-pound transducer.
So if you are going to be using that on a fixture, if that is how you're going to be determining the study, I would look at the amount of usage that may happen in between on that fixture. Typically, if you're going to be doing that on active parts, that would be another way that you could do that. So again, it's just going to be, you want to, with the gauge R&R, you want to measure the how the tool is going to be performing, and with that, you want to try to make the application rundown to be as similar as possible.
All right, and then the last question that we can take today is going to be from Patek, and it is, what class of weights are you using to perform the calibrations?
I'm not sure what the class on the weights are. To see if give us just 1 second, and we'll see if we can look at a possible cert. But if not, we can certainly get that information to you.
All right, so we'll follow up with the question about the weights. So Dave, I think that we're out of time for questions.
Class F. Okay, I've been told they're class F.
All right, and they are class F. I've had a couple people respond that they thought that, and that's confirmation they are class F. So it looks like we have it looks like we are at the end of our question and answer session here. I will follow up with you guys individually after the webinar. Recordings will be sent out within 24 hours, and you guys will each receive an email from your territory sales manager with an introduction. If you guys have any questions, feel free to email me ASAP if you want a response now. If not, you'll get something within 24 hours to get this started for you guys.
All right. Thank you so much, everyone. We look forward to seeing you on our next webinar, and hopefully we won't have a hurricane to deal with at that time. So, all right. Take care, everyone. Thanks very much.